Welcome to lecture number 3 of Industrial Electricity. Today we're going to cover chapter 4 in the text. It's going to be a short lecture today. We just have a little less material to cover, and we're going to talk about a couple of concepts, one of which is root mean square. Also, we're going to talk about mathematics, and in particular, trigonometry. So if we start with a series parallel connections, that's what we're going to talk about. So in a series connection, all elements have the same current. In a parallel connection, all elements have the same voltage. And we can use Kirchhoff's voltage law to say the sum. Actually, I do that. That's better. Of the load equals the sum of the voltage of the voltages, I should say, of the load equal voltage of the source. And that's Kirchhoff's voltage law. Voltage law. So let's draw a circuit here. If we take a battery, let's start up here. Let's back up there a little bit. Take a battery. Connect it to a light bulb. That's the symbol of the light bulb. And our battery is 120 volts DC. And we have a little observer here looking at the light bulb. He would see a certain brightness. Also, if we have another circuit, another light bulb, with an AC voltage source. And he'll look at the light bulb. And we have 120 volts. This is a DC circuit. This is an AC circuit. So the question is here is what is the voltage needed in the AC circuit to equal the voltage in the DC circuit? Okay? So basically, we want to match the brightness of the two circuits. So if we draw the AC voltage, which is sinusoidal, in this case 60 hertz, and voltage is a function of time, we have a Vmax, and a Vmin. Okay, so the question is what is needed to match the brightness of the bulb? So the answer is we need 170 volts. So let me redraw this again here. Here's our sinusoidal AC, so we need 170 volts plus and 170 volts minus. So the equation for that is VRMS, root mean squared, equals VP, the peak voltage, over the square root of 2. And that equals 170 over the square root of 2, and that equals 120 volts AC. So this is your household voltage that you see. In another case, we could determine where the magic square root of 2 comes from, but we're going to need calculus for that, and that's not in today's discussion. For today, we only need to remember that the VRMS equals VP over the square root of 2. So now we're going to talk about map of our classes. Okay. So here, today we're talking about DC. Up to today, I should say. And next, we're going to be talking about AC. And we're going to need trig for that, trigonometry. And then we're going to talk about motors. We use trigonometry in electronics. So let's take an example of a magnet. We'll draw a magnet here. We'll call this the north pole of the magnet. And we'll also draw the south pole of the magnet. And we have magnetic lines of flux that travel from the north and the south. So if we were to put a coil between these and allow it to pivot, we could induce a voltage in that coil. And we're going to indicate the position of that coil by a dot and on this side and a dot on the end and a plus sign on the other side. So that would be a coil that will pivot in the generator. As we rotate the coil, and let's see if you can see this, like this. See, there's a plus side. I'm sorry, a dot, and then the X on the other. Let me get a little closer to the camera. So as we rotate this, we can see how that looks in terms of the sinusoidal voltage. So let me draw this. Well, let's go back to yellow. I like yellow better. I think it shows up better. So we'll draw our sinusoidal voltage here. sine wave. And this is 0 degrees. This is 180 degrees. This would be 90 degrees. And this would be 270. And finally, 360 degrees. One full circle. And we had said that this would be 170 volts and minus 170 volts. This is the peak in the negative direction. So as we rotate our armature here, we can see what that voltage looks like at different positions. So over here, let's draw it in red, we'll have our dot and our X. Get a little tight here. Up at 90, we'll have our dot, and the X should be that way. At 180, we'll have the X, and then the dot this way. At 270, it would be the X, and the dot would be in that direction. And finally, at 360, it would be the same as 0 again, right? So the dot would be that way, and the X would be this way. So in other words, the dot would be up. That would be 0. At 90, it's this way. At 180, it's this way. At 270, I'm sorry, 180 is X up. 270 is this way. And finally, 360 is back this way. Okay, I actually made an error here. This is not right. I needed to draw this horizontally. So let's just erase that. Oh, that's a white one. Where's the eraser? Yeah, it's not working. Oh well. We'll just draw this, go back to red here. Oh, there's the eraser. Okay, there we go. Wrong one. That's better. So now the X would be this way, and our dot would be that way. Okay. All right, so now we're going to show our, we're going to talk about trigonometry. Okay, trigonometry. We're going to solve for a triangle. So we know for a triangle that some of the angles is equal to 180 degrees. We also use the Pythagorean theorem. So if we draw a triangle here, like so, and we call this the adjacent side, and there's an angle theta here, and this is the opposite side, and this is the hypotenuse, we can state that the sine of theta equal to O over H. In other words, the opposite over the hypotenuse, and the cosine of theta equal to adjacent over the hypotenuse, and the tangent theta equal to the opposite over adjacent. So those are the three main trigonometric functions that you can determine the angle, or you can find, if you know the angle, you can find any of the sides of the triangle. So let's look at an example. So we have a triangle. We have a 40-degree angle. It's 15 feet long, and we want to know x. So we use, we're going to use the tangent. Use the tangent of theta to solve this. So tangent of 40 degrees equal to x over 15. So x equals 15 tangent of 40 degrees. And x equals, let's try it in our calculator here. Let's see, there we go. So if we take, we're going to take 15 times the tangent of 40 degrees. And that equals 12.58, so we'll call it 12.6 feet. Also, just a reminder, when you're using trigonometric functions on your calculator, just make sure there's a little d up here, because that's degrees. The calculator will work in degrees or radians, and if you are in radians, you're going to have quite a different result. Okay, going back to our example here, which trigonometry, we know that this is a right triangle, so that's an 90-degree angle. There's another angle here, we'll call this phi. So the angle of angle phi equals 180 degrees minus 40 degrees minus 90 degrees. And that equals 50 degrees. So remember that all the angles of a triangle sum to 180 degrees. Okay. look at another example. We have a triangle, a right triangle. We have an angle theta, and whose sides are 12 and 4. So here we're going to calculate the hypotenuse of the triangle, which we'll call C this time, and we'll use the Pythagorean theorem to do that. So the Pythagorean theorem says a squared plus b squared equals c squared, or c equals the square root of 12 squared plus 4 squared, and that equals 12.6. And I'll let you folks try that on your calculator. We also can use the function called the arctangent to calculate the angle. So we can, the tangent of theta is equal to 4 over 12 in this example. And so now what we'll do is we'll use the arctangent, ARC, tan, arctan, also called inverse tangent. So we can use the inverse tangent to solve for theta in this example. So we denote that as the tan to the minus 1 power, just as you would have 1 over x, and x can also be expressed as x to the minus 1 because it's in the denominator. The arctan of the tangent of theta, and that would be equal to the arctangent of 4 divided by 12. So theta would equal 18.4 degrees. What I'll show on the calculator here is how the tangent, the arctangent of a tangent, becomes the original angle. So if you hit arctangent, which is a shift tangent of, then we can say the tangent of 30, and that equals 30. How about that? The tangent, the arctangent of the tangent equals the original angle. And that's going to be it for today. So have a safe Labor Day.